Hello students, welcome to video lecture classes, second PUC chemistry organized by Mysuru district PU chemistry lecturers forum. You are watching my PU chemistry YouTube channel. Kindly subscribe to the channel and also press the bell icon to get regular updates. So in our previous videos, we discussed about solutions and we also discussed about concentration of solutions. We have understood that there are several ways for expressing concentration of solutions. So these are known as units of concentration. So among those units of concentration, in the last video we have discussed three of them, 3 units of concentration, and we have also solved certain numerical problems based on those units. Okay. ನಮ್ಮ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋನಲ್ಲಿ ನಾವು ಮಾಸ್ ಪರ್ಸೆಂಟೇಜ್, ವೇಟ್ ಬೈ ವೇಟ್, ದೆನ್ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್, ವಾಲ್ಯೂಮ್ ಬೈ ವಾಲ್ಯೂಮ್, ದೆನ್ ಮಾಸ್ ಬೈ ವಾಲ್ಯೂಮ್ ಪರ್ಸೆಂಟೇಜ್, ವೇಟ್ ಬೈ ವಾಲ್ಯೂಮ್. ಸೊ ಇಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಯೂನಿಟ್ಗಳದು ನಾವು ಅದರ ಮೀನಿಂಗ್ ಏನು ಮತ್ತು ಅದನ್ನು ನಾವು ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಹೇಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನೋದನ್ನು ನಾವು ಕಲ್ತಿದ್ದೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ unit for expressing concentration, what we have, we call it as mole fraction. This is our 4th unit. Mole fraction. Okay. Now let us assume we have two components A and B. In a solution we have two components A and B. Now NA is number of moles of A and NB is number of moles of B. So there is a solution which is made by mixing the component A and component B. How much of A is present? NA moles of A is present, and how much of B is present? NB moles of B is present. Okay. Now mole fraction with respect to A would be, mole fraction with respect to A would be number of moles of A divided by total number of moles of all the components present in the solution. Number of moles of A divided by total number of moles of all the components present in the solution. Then similarly, mole fraction with respect to B is number of moles of B divided by total number of all components present in the solution. So this is how we express concentration in terms of mole fraction. So allige definition enaitu, mole fraction of a particular component is defined as the ratio between the number of moles of that component to total number of all the components present in the solution. Okay. So mole fraction with respect to any particular component in a solution, it is defined as the ratio between the number of moles of that particular component to the total number of all the total number of moles of all the components present in the given solution. So this is how we define mole fraction. So mole fraction is the ratio between the number of moles of a component to total number of moles of all the components present in the solution. Present in the solution. Now in the example that we have chosen, there are only two components. If there are more than 2 components, then include all of them. That's all. If there are n number of components, for example, mole fraction with respect to component number 1, it is the number of moles of ratio between number of moles of first component to total number of all the components. If there are n components, 1 to n, then mole fraction with respect to every component can be expressed in this format. So this is about mole fraction. Now let us take up certain numerical problems so that we understand the concept of mole fraction in a more clear manner. Okay. Now this is the problem for us. The problem gets popped up on the screen. Please note down the problem in the beginning, then go ahead with the solution. Okay. Now the problem is, a solution is prepared by dissolving 1.2 grams of urea in 36 grams of water. A solution is prepared by dissolving 1.2 grams of urea in 36 grams of water. Calculate mole fraction of urea in water. Calculate mole fraction of urea in water. So this is the problem for us. Now we have a solution. We have a solution of urea dissolved in water. Urea is an organic compound. Urea is an organic compound which is soluble in water, that is used as fertilizer for cultivating various crops. Okay. Now we have this is problem number 5. As usual, let us copy down what is given in the problem. Okay. So weight of urea is given as 1.2 grams. 1.2 grams of urea is dissolved in 36 grams of water. So weight of water will be 36 grams. We have to find out the mole fraction of urea. Now in order to find out mole fraction, here we have the formula for us. We can take the number of moles of urea. We have to divide it with the total number of moles of all the components, that is number of moles of urea plus number of moles of water. Okay. But in the question, number of moles is not given. Instead of that, weight is given in grams. What is the mass of urea dissolved in what mass of water? Only so much is given. Number of moles is not given. Question alli ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಷ್ಟು ಗ್ರಾಮ್ಸ್ ಯೂರಿಯಾ ಎಷ್ಟು ಗ್ರಾಮ್ಸ್ ವಾಟರಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ ಅಷ್ಟನ್ನು ಮಾತ್ರ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ. ಆದರೆ ನಮಗೆ ಫಾರ್ಮುಲಾನಲ್ಲಿ ಬೇಕಾಗಿರೋದೇನು, ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್. ಓಕೆ. ಈಗ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸನ್ನು ನಾವು ವೇಟ್ ಇನ್ ಗ್ರಾಮ್ಸನ್ನು ನಾವು ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ಗೆ ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು, ಅದಕ್ಕೆ ನಮಗೇನು ಗೊತ್ತಿರಬೇಕು, ವಿ ನೀಡ್ ಟು ನೋ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಯೂರಿಯಾ. ವಿ ನೀಡ್ ಟು ನೋ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಯೂರಿಯಾ. ಓಕೆ. ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಯೂರಿಯಾ ಏನಾಗುತ್ತೆ, ಯೂರಿಯಾದ ಫಾರ್ಮುಲಾ NH2CO NH2. ಸೊ ನಮಗೆ 2 ನೈಟ್ರೋಜನ್ ಇದೆ, 2 × 14, correct. Then we have 4 hydrogen, 1 × 4, okay, or let me write it 4 × 1, 4 hydrogen atoms, mass of hydrogen atomic mass is 1. Then carbon, we have 1 carbon, then oxygen 1 × 16. This is 28, this is 4, this is 12, this is 16. If we add up, we get 0, 2, 6. So molar mass of urea is 60 gram per mole. So we write molar mass in terms of gram per mole. What does that mean? If you take 1 mole of this solute, 1 mole of this substance, the weight will be 60 grams. We can also call it as gram molecular mass. Gram molecular mass anta adru karitivi, illa antandre molar mass anta karitivi. Molar mass andre ಒಂದು ಮೋಲ್ಗೆ ಎಷ್ಟು ಮಾಸ್ ಆಗುತ್ತೋ ಆ ಮಾಸನ್ನು ನಾವು ಮೋಲಾರ್ ಮಾಸ್ ಅಂತ ಕರಿತೀವಿ. Similarly, we should know molar mass of water, which is 18 gram per mole. We can similar way calculate. Oxygen is 16, hydrogen is 1 plus 1 will be 18. Okay. Now, after knowing this, we can find out number of moles very easily. How do we find out number of moles? Nodi, 60 grams of urea is 1 mole. That means if you take 1 mole of urea and weigh it, you get 60 grams. 1.2 grams of urea is how many mole? That is all what we need. Once we have number of moles, we can substitute it in the formula. So, enaitalige 1.2 divided by 60. The same thing we express in terms of formula. Enanta karitivi? Number of moles N is equal to, okay, weight in grams divided by molar mass. So, how did we get this formula? It is just like this. 1 molar mass of any substance gives you 1 mole. How much ever weight we have, weight in grams that we want to convert it in terms of moles, that gives how many moles. If we equate this, we will get this format. This itself is expressed in the form of this formula. Therefore, number of moles is equal to weight in grams divided by molar mass. This is an important formula that we have to remember, so that we can directly apply when we are solving problems. Number of moles find out ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, weight in grams the number of moles ಗೆ convert ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ, here is the formula for us. Number of moles is equal to weight in grams divided by molar mass. Okay. So, how much do we get? 1.2 divided by 60. Then for this we get number of moles of urea. Urea is equal to 1.2 divided by 60. This is 0.02. 0.02. Then similarly, number of moles of water. How many grams of water we have? 36 grams. And what is the molar mass of water? 18 grams. So, this is 2 moles. Oh, I am sorry. Is that correct? Yeah. So, we have 2 moles. Now, we can substitute them in the formula. We get mole fraction of urea is equal to number of moles of urea divided by number of moles of urea plus number of moles of water. So, number of moles of urea is 0.02, then number of moles of water will be 0.02 plus 2. So, this will be 0.02 divided by 2.02. This is close to 2 into 10 to the power minus 2 divided by 202 into 10 to the power minus 2. So, here we can easily cancel out (10 to the power minus 2). So, this will be 1 by 101. That is 1 by 101 is 1 by 100, or you get slightly close to 0.009, close to this value. So this is the mole fraction of urea in terms of expressing the concentration of urea in mole fraction. Okay. Now let us take up another problem. Problem number 6. Calculate the mole fraction of benzene in a solution containing 30% by mass of carbon tetrachloride. So in this problem, the amount of benzene dissolved or the amount of carbon tetrachloride dissolved, amount in the sense weight in terms of grams, ಎಷ್ಟು ಗ್ರಾಮ್ ಬೆಂಜೀನ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆ, ಎಷ್ಟು ಗ್ರಾಮ್ ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆ ಅನ್ನೋದು ಡೈರೆಕ್ಟಾಗಿ ಕೊಟ್ಟಿಲ್ಲ. ಓಕೆ, ಒಂದು ಸೊಲ್ಯೂಷನ್ ಇದೆ, ಇದರಲ್ಲಿ ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಮತ್ತು ಬೆಂಜೀನ್ನ ಮಿಕ್ಸ್ ಮಾಡಿ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಮಾಡಿದ್ದಾರೆ. ಎಷ್ಟು ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡನ್ನು ಎಷ್ಟು ಬೆಂಜೀನಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡಿದ್ದೀವಿ ಹೇಳಿಲ್ಲ, ಅಂದರೆ ಡೈರೆಕ್ಟಾಗಿ ವೇಟನ್ನು ಹೇಳಿಲ್ಲ. ಸೊ ಏನು ಹೇಳಿದ್ದಾರೆ, the solution's concentration is expressed in some other unit, in some unit. ಯಾವ ಯೂನಿಟ್ ಅದು ಏನಂತ ಹೇಳಿದರೆ, the concentration of this unit is, the concentration of this solution is, the concentration of solution is expressed in terms of mass percent, 30% weight by weight of carbon tetrachloride in benzene. 30% weight by weight of carbon tetrachloride in benzene ಅಂತ ಹೇಳಿದ್ದಾರೆ ಅಲ್ವಾ. ಓಕೆ, ಸೊ ನೋಡಿ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಏನಿತ್ತು, so much amount of solute is dissolved in so much amount of solvent, express the concentration in mole fraction ಅಂತ ಡೈರೆಕ್ಟಾಗಿ ಕೇಳಿದರು. ಓಕೆ, ಬಟ್ ಇಲ್ಲಿ ಏನು ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ನ ಆಲ್ರೆಡಿ ಒಂದು ಯೂನಿಟಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿಬಿಟ್ಟು you are asked to change the unit, you are asked to express the concentration in different unit. So ಈ ಥರ ವೆರೈಟಿಯಾಗಿ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನು ಕೇಳ್ತಾರೆ. Sometimes directly the weights are given and you are asked to express the concentration in a certain unit. In certain other cases, the concentration is already expressed in a particular unit. You will be expected to express the concentration of the same solution in some other unit. ಸೊ ಇಲ್ಲಿ ಆ ಥರ ಇದೆ. ಸೊ ನಮಗೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗೊತ್ತಿದೆ 30% ವೇಟ್ ಬೈ ವೇಟ್ ಅಂತ. ಓಕೆ, ಸೊ ಅಂದರೆ ಏನರ್ಥ, 30% ವೇಟ್ ಬೈ ವೇಟ್ ಆಫ್ ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಬೆನ್ಝೀನ್. ಸೊ ವಾಟ್ ಡಸ್ ದಿಸ್ ಆ್ಯಕ್ಚುಲಿ ಮೀನ್? ಸಪೋಸ್ ವಿ ಸ್ಟಾರ್ಟ್ ವಿತ್ 100 grams of solution. Suppose we start with 100 grams of solutions. Then what does this mean? This means 100 grams of the solution contains 30 grams of carbon tetrachloride in 70 grams of benzene. This is what it means. Alva? Similar kind of problems we have discussed in previous video. Alva? So 30% weight by weight of carbon tetrachloride in benzene ಅಂದರೆ ಏನರ್ಥ, 100 grams of solution ತೊಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ 30 ಗ್ರಾಮ್ ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಇರುತ್ತೆ, 70 ಗ್ರಾಮು ಬೆನ್ಝೀನ್ ಇರುತ್ತೆ. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಸೊ ದ ವೇಟ್ ಆಫ್ ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಈಸ್ 30 grams. We also need molar mass of carbon tetrachloride because we have to find out number of moles. So molar mass of carbon tetrachloride will come close to carbon is 1 into 12 plus chlorine is 35.5 atomic weight into 4. So this will be 154 gram per mole. Then we also have to find out number of moles of carbon tetrachloride. ಯಾಕೆ mole fraction of carbon tetrachloride find out ಮಾಡಬೇಕು ಅಂತಂದರೆ number of moles of carbon tetrachloride divided by number of moles of carbon tetrachloride plus number of moles of benzene. So ಅದಕ್ಕೋಸ್ಕರ ನಾವು we have to find out number of moles of carbon tetrachloride, which is given by the formula weight of carbon tetrachloride divided by molar mass of carbon tetrachloride. Alva? So this is the formula we have to apply. How we get this formula I have explained in the last problem. Alva? So whenever we want to find out the number of moles, remember this formula. So ಇಲ್ಲಿ ನಾವು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮ್ಗೆ ಏನು ಬರುತ್ತೆ, weight is 30 grams, number of molar mass is 154 grams. So ಇದನ್ನು ನಾವು ಡಿವೈಡ್ ಮಾಡ್ತು ಅಂತಂದರೆ we get 0.195 moles. Number of moles is 0.195. You can say number of moles is 0.195. So similarly, we know that the weight of benzene is how much? 70 grams. Then molar mass of benzene ಎಷ್ಟಾಗುತ್ತೆ? 6 into 12 plus 1 into 6. 12 5s are 60, 72. 72 plus 6 is 78 gram per mole. Similarly, we calculate number of moles of benzene. So ಎಷ್ಟಾಗುತ್ತೆ? Weight of benzene divided by molar mass of benzene. Weight of benzene 17 grams ಇದೆ, molar mass 78 grams ಇದೆ. So we get 0.897. So ಇಷ್ಟು ಗೊತ್ತಾದಮೇಲೆ it is easy for us to find out the number of moles. I mean mole fraction. ಓಕೆನಾ? ನಾವು ಡೈರೆಕ್ಟಾಗಿ ಫಾರ್ಮುಲಾನಲ್ಲಿ ಇವಾಗ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಸೊ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಆಫ್ carbon tetrachloride is equal to number of moles of carbon tetrachloride divided by number of moles of carbon tetrachloride plus number of moles of benzene. That is total number of moles of all the components present in the solution. Okay, number of moles of carbon tetrachloride is 0.195 divided by 0.195 plus 0.897. So if we simplify this, we get 0.179. This is mole fraction of carbon tetrachloride. Now what will be the mole fraction of benzene? Okay, we can again substitute number of moles of benzene, number of moles of carbon tetrachloride, number of moles of benzene. ಈ ಥರ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿಕೊಂಡು ಮಾಡಬಹುದು. ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಬೆನ್ಝೀನ್ ಎಷ್ಟಿದೆ? 0.897 ಡಿವೈಡೆಡ್ ಬೈ 0.195 ಪ್ಲಸ್ 0.897. ಆ ಥರ ಬೇಕಾದರೂ ಮಾಡ್ಬೋದು. ಆಲ್ಟರ್ನೇಟಿವ್ಲಿ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಡೂ ಇಸ್ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಆಫ್ ಬೆನ್ಝೀನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಮೈನಸ್ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಆಫ್ ಕಾರ್ಬನ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ಅಂತ ಮಾಡ್ಕೋಬೋದು. ಹೇಗೆ ಅಂತ ಕೇಳಿದ್ರೆ ನೋಡಿ, ಫ್ರ್ಯಾಕ್ಷನ್ಗಳನ್ನು ನಾವು ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋದರೆ ಎಲ್ಲ ಫ್ರ್ಯಾಕ್ಷನ್ನು ಸೇರಿಸ್ಬಿಟ್ರೆ ಆಲ್ವೇಸ್ ದ ಆನ್ಸರ್ ವಾಟ್ ವಿ ಗೆಟ್ ಈಸ್ 1. ಕರೆಕ್ಟ್? ಆಲ್ ದ ಪರ್ಸೆಂಟೇಜ್ ಯು ಆ್ಯಡ್ ಅಪ್, ದ ಟೋಟಲ್ ವಿಲ್ ಬಿ 100. ಹೇಗೋ ದಿ ಟೋಟಲ್ ಆಫ್ ಆಲ್ ದ ಪರ್ಸೆಂಟೇಜ್, ದ ಟೋಟಲ್ ಫಾರ್ ಪರ್ಸೆಂಟೇಜ್ ಈಸ್ 100 ಆಲ್ವೇಸ್ ಅಲ್ವಾ? ಸಿಮಿಲರ್ಲಿ ದ ಟೋಟಲ್ ಫಾರ್ ಆಲ್ ದ ಫ್ರ್ಯಾಕ್ಷನ್ಸ್. ಓಕೆ, ಫ್ರ್ಯಾಕ್ಷನ್ ಅಂದರೆ ಏನು? ಒಂದು ಹೋಲ್ ಇರೋದ್ರಲ್ಲಿ ನಾವು ಎಷ್ಟು ಭಾಗ ಮಾಡಿದ್ದೀವಿ, ಎಷ್ಟು ಪಾರ್ಟ್ಸ್ ಮಾಡಿದ್ದೀವಿ, ದಟ್ ಇಸ್ ವಾಟ್ ಈಸ್ ಮೆಂಟ್ ಬೈ ಫ್ರ್ಯಾಕ್ಷನ್. ಈಗ ಒಂದು ಆ್ಯಪಲ್ ತೊಗೊಂಡು ಈಕ್ವಲ್ ಹಾಫ್ಸ್ ಮಾಡಿ. ಸೊ ಇದು ಹಾಫ್. ಓಕೆ, ಒನ್ ಪೀಸ್ ಒನ್ ಹಾಫ್, ಒನ್ ಮೋರ್ ಪೀಸ್ ಅನದರ್ ಹಾಫ್, ಎರಡು ಸೇರಿಸ್ಬಿಟ್ರೆ 1. ಯು ಮೇಕ್ ಇಟ್ 4 ಪಾರ್ಟ್ಸ್, 1/4, 1/4, 1/4, 1/4, ಆ್ಯಡ್ ಅಪ್, ಹೋಲ್ ಇಸ್ 1. ಸೊ ಆಲ್ವೇಸ್ ದಿ ಟೋಟಲ್ ಆಫ್ ಆಲ್ ದ ಫ್ರ್ಯಾಕ್ಷನ್ಸ್ ಈಸ್ 1. The total of all the mole fraction also has to be 1. Correct? So total is 1. Mole fraction of carbon tetrachloride is so much. So subtract ಮಾಡಿ ನೋಡಿಕೊಂಡ್ರೆ ನಮಗೆ ಇದು ಸಿಕ್ಕಿಬಿಡುತ್ತೆ. So 1 minus 0.179. So the answer that we get is 0.821. ನೀವು ಇದಕ್ಕೆ ಈ ಫಾರ್ಮುಲಾನಲ್ಲಿ ನಮಗೆ ಏನೇನಿದೆ, ಈ ಜಾಗದಲ್ಲಿ 0.897 ಡಿವೈಡೆಡ್ ಬೈ 0.195 ಪ್ಲಸ್ 0.897 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿಕೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡು ನೋಡಿ, ಆಗಲೂ ಕೂಡ ಇದೇ ವ್ಯಾಲ್ಯೂ ಖಂಡಿತ ಬಂದೇ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್. ಸೊ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ ಈಸ್ ಆನ್ ಇಂಪಾರ್ಟೆಂಟ್ way of expressing concentration. We will be using this while understanding about relative lowering of vapor pressure. ಇದೇ ಚಾಪ್ಟರ್ನಲ್ಲಿ ಮುಂದೆ ಕಾಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟೀಸ್ನಲ್ಲಿ ರಿಲೇಟಿವ್ ಲೋವರಿಂಗ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಅಂತ ಇದೆ. ಸೊ ಅದನ್ನು ನಾವು ಓದಬೇಕಾದ್ರೆ ಮೋಲ್ ಫ್ರ್ಯಾಕ್ಷನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಓಕೆ, ದೆನ್ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಟರ್ಮ್, ನೆಕ್ಸ್ಟ್ ವೇ ಆಫ್ ಎಕ್ಸ್ಪ್ರೆಸಿಂಗ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸ್ ಮೊಲಾರಿಟಿ. This is also very important concept. This is 5th unit of concentration that we are discussing. The unit is molarity, designated by the letter capital M. Okay. Now, let us consider another solution. Say for example, we have a solution of, let us say, sodium hydroxide in water. Sodium hydroxide in water. So what I have done is, in 1 liter of this solution, 1 liter of this solution contains 1 mole of sodium hydroxide. Let us assume we have a solution of sodium hydroxide. 1 liter of that solution contains 1 mole of sodium hydroxide. Then the concentration of such a solution is said to be 1 molar. Okay, that means if 1 mole of a solute is dissolved in 1 liter of the entire solution, then the concentration of such a solution becomes 1 molar. Okay, supposing we have another solution, same sodium hydroxide, I have 2 moles in 1 liter, then concentration will be 2 molar. Similarly, if I have 5 moles in 1 liter, the concentration will be 5 molar. Similarly, if I have 0.5 moles in 1 liter, concentration will be 0.5 molar, or 0.5 moles in 0.5 liters, it will be 1 molar. Now, what is molarity? Molarity is number of moles of a solute dissolved in 1 liter or 1 dm cube of a solution. So molarity is defined as, it is number of moles of solute of a component dissolved in, present in 1 liter, 1 dm cube, both are same, of solution, 1 liter of solution. This is what we mean by molarity. Okay. Now, the unit for molarity is mole per liter, or we write mole per dm cube. This itself is known as, or this itself is designated as capital M. Okay. Now, what is the formula? Mathematically, how we can express the same thing? Molarity, see, it is the number of moles of solute or a component, a particular component, divided by volume of solution, which is in liters. So this is what we express, this is how we express molarity. Now in place of number of moles, instead of number of moles, we have weight in grams. We have weight of the solute. Usually we designate solute as weight of the solute, weight of solute, weight in grams. Let us assume it is WB grams. B always refers to solute, A always refers to solvent. if we have a binary solution of a solute in solvent, one solute, one solvent, binary solution, then the subscript B refers to solute usually, the subscript A refers to solvent. Okay. If WB grams of solute is dissolved in certain volume of solution, the molar mass or molecular mass of solute being MB gram per mole, then how much will be number of moles of B? This will be WB divided by MB, correct? For finding number of moles, we can apply this formula, weight in grams divided by molar mass. If we substitute this in the molarity equation, then we get molarity is equal to weight of solute in grams divided by molar mass of solute whole divided by volume of solution, if this is in liters, or simplified form we get WB divided by MB into 1 by L, or you can take this because the denominator goes to numerator, so you get volume. This volume is expressed in liters. In case we have volume expressed in ml instead of liters, if the volume is expressed in cm cube or ml, then we have to convert the volume in ml into volume in liters. How we can do it? We can do it by dividing this by 1000, correct? Because 1 liter is equal to 1000 ml, or 1 ml is equal to 1 by 1000 liter, or 0.001 liter. So we can take this. So if we have volume expressed in ml, say around 10 ml, how do you convert it into liters? 10 divided by 1000. So we can take this as, if volume is expressed in molarity is equal to volume, if it is expressed in ml, then we have WB by MB, this is number of moles, whole divided by volume, if it is expressed in ml, we divide it by 1000. So the denominator goes to numerator, then we get molarity is equal to weight of solute divided by molar mass of solute into 1000 by volume that is expressed in ml. So that is known as molarity equation. So we have this equation, molarity is equal to WB by MB into 1000 divided by volume of solution, which is expressed in ml. So this is the important formula which we will be using to solve problems. So WB refers to weight of solute in grams, MB refers to molar mass of solute, then V is volume of the solution in ml. So having known so much, we can take up problems on molarity. Okay. So let us solve certain problems. Yeah, this is the problem for us. Calculate the molarity of a solution containing 5 grams of sodium hydroxide in 450 ml of solution. This is 7th problem. Calculate molarity of a solution obtained by dissolving 5 grams of NaOH in 450 ml of solution. So we have, we can copy what is given. So weight of NaOH, which we usually write weight of solute is 5 grams. Okay. You can directly take weight of NaOH, write the same thing in the formula. There is nothing wrong in that. But usually these are standard notations that we use while solving problems. So when we write WB, we should understand that it is weight of solute. Okay. Then volume of the solution is given. Volume of the solution is given, which is 450 ml. So volume of the solution is given in ml. Then weight of NaOH is given in terms of grams. Then we can directly apply this formula. Okay. Now, what do we get? We have to find out number of moles. Number of moles, or without finding number of moles also it can be done. Molar mass of NaOH we should know for sure is sodium is 23, 1 into 23 plus oxygen is 16 plus hydrogen is 1. So this comes to 40 gram per mole. This comes to 40 gram per mole. So what do we have? Molarity is equal to weight of solute divided by weight of molar mass of solute into 1000 divided by volume of the solution in ml. So we have weight of solute is how much? 5 by 40 into 1000 divided by 450. Now if we solve this, the answer that we get is 0.278 designated by the letter capital M. Sometimes we write it as 0.278 mole per liter. That also means molarity. Okay. So this is the solution for the problem. Then let us take up another problem. Calculate the amount of benzoic acid required for preparing 250 ml of 0.15 molar solution in methanol. Calculate the amount of benzoic acid required for preparing 250 ml of 0.15 molar solution in methanol. Okay. Now how do we do it? Problem number 8, solution for this. What is given? So we have a solution of benzoic acid which is prepared in methanol. Benzoic acid is prepared in methanol. So molarity of the solution is given. Molarity of the solution is given to be 0.15 molar. Molarity of the solution is given to be 0.15 molar. Then volume of the solution is given to be 250 ml. Volume of the solution is given as 250 ml. Then we have to find out how much benzoic acid is required if we want to prepare this concentration, this much volume of solution. Okay. Now we can directly substitute all these values in the molarity equation, but we have to know the molar mass of benzoic acid. Molar mass of benzoic acid, C6H5 COOH, molar mass of benzoic acid, and this is, by the way, benzoic acid. It contains a benzene ring and a carboxylic acid. You will study about these compounds in the chapter aldehydes, ketones and carboxylic acids in organic chemistry. Okay. Though MB will be how much? 6 plus 1, 7 into 12 plus 6 into 1 plus 2 into 16. So we add up all this and the final answer that we get is 122 gram per mole. ಇಷ್ಟು ಬರುತ್ತೆ ಹೌದಾ. ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ನಾವು ಮೊಲಾರಿಟಿ ಈಕ್ವೇಷನ್ ತಗೊಳ್ಳೋಣ. ಮೊಲಾರಿಟಿ ಈಕ್ವೇಷನ್ weight of solute divided by molar mass of solute into 1000 divided by volume of solution in liters. ನಾವಿಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿರೋದು ವೇಟ್ ಆಫ್ ಸೊಲ್ಯೂಟ್ ರಿಕ್ವೈರ್ಡ್. ಓಕೆ, ಸೊ ಎಷ್ಟಾಗುತ್ತೆ? ಮೊಲಾರಿಟಿ 0.15 ಇದೆ, ವೇಟ್ ಆಫ್ ಸೊಲ್ಯೂಟ್ ಕಂಡುಹಿಡಿಬೇಕು. ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ದಿ ಸೊಲ್ಯೂಟ್ ಎಷ್ಟಾಗಿದೆ? 122 ಗ್ರಾಮ್ಸ್ ಆಗಿದೆ. ಗ್ರಾಮ್ ಪರ್ ಮೋಲ್ 1000 divided by 250. Now upon simplification of all these values, so WB what we get is 0.15 into 122 into 250 divided by 1000. Is that correct? So this comes up to 4.575 grams. So how do we actually prepare it? So this is what we have calculated. So we weigh 4.575 grams of solid benzoic acid, then dissolve it in small amount of solution, small amount of solvent. What solvent we have? The solvent that we have is methanol. Dissolve it thoroughly. Then this is transferred to a specialized flask, what is known as volumetric flask. You get it in different quantities. Take 250 ml volumetric flask, that amount of solvent is dissolved. Then there is a marking in this, which means if you take any solution or any liquid up to that level, it is 250 ml. Then add more amount of solvent, that is methanol, and make up the volume up to 250 ml. This is how we prepare standard solutions.